Every day you look through glass without ever stopping to wonder where it came from. It quietly shapes your view of the world, framing your cities, your homes, and your technology. Glass surrounds modern life. It fills our windows, our doors, and our buildings, allowing light to enter while protecting us from the outside environment. From smartphone screens to towering skyscrapers, glass connects technology, design, and daily living in ways few materials ever have. It does more than reflect cities, it allows them to see themselves. The flawless surface you see today began as something far less refined. The story of glass begins with sand. Not all sand can become glass. Only sand rich in silica contains the structure needed to transform into transparent material. Inside each grain of silica sand lies the chemical foundation of glass. This sand is collected from deserts and quarries around the world. It is transported to glass facilities where it begins its transformation. Before it can be used, the sand must be washed and purified to remove unwanted minerals. Technicians carefully measure silica sand, soda ash, and limestone, the three essential ingredients of glass. Together, these materials form the basic recipe that has remained nearly unchanged for centuries. Long before factories existed, early humans may have discovered glass accidentally when intense fire fused sand together. These crude glass pieces hinted at a new material unlike anything found in nature. Ancient Egyptians were among the first civilizations to intentionally manufacture glass. Glass quickly became valued for jewelry, ornaments, and ceremonial objects. The Romans later revolutionized glassmaking with the invention of glass blowing. Glass blowing allowed molten glass to be shaped quickly and efficiently. This innovation made glass windows possible for the first time. During the Middle Ages, glass became both functional and artistic. Stained glass windows transformed cathedrals into stories made of light and color. By the industrial age, glassmaking was ready to change again. Large furnaces brought glass production into the modern world. Industrial furnaces allowed glass to be produced on a massive scale. At extremely high temperatures, sand melts into glowing liquid glass. Production now depended on precision, control, and timing. Early factories rolled molten glass into flat sheets. These sheets were imperfect, but they opened the door to modern architecture. Everything changed with the invention of float glass. Molten glass was floated on liquid tin to form perfectly flat sheets. The glass then cooled slowly to increase strength and reduce internal stress. Large sheets were cut into precise sizes. Polishing created smooth edges and clear surfaces. Each glass panel is inspected under high-intensity lighting to detect bubbles, scratches, and structural flaws. Selected panels are heated again in tempering furnaces and rapidly cooled with air jets. This process increases strength and causes the glass to shatter safely if broken. Finished glass panels are transported to construction sites and installed into building frames. Residential homes use glass windows and doors to allow natural light while maintaining insulation and security. Modern skyscrapers rely on curtain wall glass systems that cover entire building exteriors. Special furnaces heat and bend automotive glass into curved windshields and windows. Robotic systems install windshields into vehicle frames using industrial adhesives. Drivers view roads, signals, and surroundings through precision-manufactured safety glass. Public transportation systems use reinforced glass for visibility and passenger protection. Office buildings use glass walls and partitions to improve lighting and openness. Retail stores use glass storefronts to display products and attract customers. Glass windows protect indoor spaces from wind, rain, and temperature changes. City skylines are defined by reflective glass building facades. Glass technology expanded beyond buildings into digital devices. Smartphones and tablets use strengthened glass screens as their primary interface. All digital touch input occurs through glass surfaces. Display glass is manufactured in clean room facilities to prevent contamination. Glass screens undergo drop, pressure, and scratch resistance testing. Optical glass is used in cameras, microscopes, and telescopes. Precision lens assemblies convert light into digital images. Medical imaging systems rely on optical glass for accurate diagnostics. Laboratory glassware is engineered to withstand heat and chemical exposure. Fiber optic cables use glass fibers to transmit data as light pulses. Global communication networks are built on glass-based fiber optics. Eventually, glass products reach the end of their service life. Used glass is collected for recycling. Recycled glass is crushed into cullet. Cullet is melted and reused to produce new glass. Modern glass plants use energy-efficient furnaces to reduce emissions. Recycled glass is installed in new buildings. Glass bottles are cleaned and reused. Solar panels use protective glass covers. Smart glass is being developed to control heat and light. Research laboratories continue improving glass performance. Glass remains a core material of daily life. It often goes unnoticed. Cities depend on glass infrastructure. Glass connects interior and exterior environments. From raw sand to advanced technology, glass production reflects how humans learn to engineer light and space.